Hey, what's up, chat? Welcome to Unit 9, Day 2. In this lesson, we are finding the probability of two independent events. Okay, in the last lesson, we learned the difference between independent and dependent events. Okay, and what we learned was an independent event, what you do the first time or the first event has no effect on the second event. And for a dependent event, it does affect it, okay? And so we're gonna see that further in the last lesson. All we were doing was identifying whether it was independent and dependent. In this lesson and in the next, we're actually gonna be finding and calculating the probability. So let's get to it, all right? So independent events are not affected by the previous event, okay? And so what I do the first time, when I say event, I'm talking about whatever it is that I'm doing in that problem. Maybe it's removing a marble or picking a card or rolling a dice. Those are all events, okay? And so whatever in an independent, the first one does not change the second one, okay? It doesn't affect it, all right? And these are the same steps for both independent and dependent events. Step one is we have to find the probability. Okay, so we are going to find the probability of the first event. Then we are going to find the probability of the second event. Okay. Thirdly, we are going to multiply. So we have our probability of our two events, then we're going to multiply them. And then the last and final step is that we need to simplify or reduce. Okay, so most times our answers are going to be written as fractions. Sometimes it's decimals, sometimes as percent. But if it's written as a fraction, we need to make sure that we simplify it. Okay, so let's get to it. Let's look at this first example. All right, Courtney has a box that contains 10 socks. She has 5 green, she has 3 black, and she has 2 blue. Okay. What is the probability that Courtney reaches into the box and grabs a green sock, replaces the sock, and then grabs a blue sock? Okay, so the fact that she replaces the sock is huge, right? That is what makes this an independent event. Okay, so she grabs a green sock. So I'm looking for the probability of getting a green. Okay, then I'm going to multiply that times the second, which is the probability of getting a blue. And friends, I want to encourage you. This is how I set up my problem whenever I'm finding probability, because it helps me identify. You're going to always likely be given more information than you need. So you need to make sure that you are focusing in on the correct parts. Okay, so I'm finding the probability of green, then multiply it times the probability of blue. And that's going to give me the probability of those two events. Okay, so what's the probability of a green? Well, we have 5 green socks. Out of how many? Well, I could add these up, but it also does give me the total in this problem, and they won't always give you the total. Usually you may just have to add them up, making sure you don't forget any or leave any out. So we got 5 over 10 times the blue is 2 over 10, okay? And again, because these are independent, the total's not going to change, okay? What I get the first time has no effect on what I get the second time, all right? And then I just multiply these, okay? And so when I multiply, again, these two fractions are pretty simple to multiply, but a lot of times you're going to have some that are maybe a little harder. So what I do is I do want you to get used to making sure that you're using the decimals calculator in order to multiply these. So I'm just going to do that here for you just to model that, but again, this is just what you should be doing. All right, so we got 5 over 10, okay, times 2 over 10, all right, and I got 0.1, all right, and so 0.1 is my number as a decimal, okay, and so a lot of times your answer might be given as a fraction, so it's going to be important that you know what the fraction value is as well. So, okay, so this is 0.1, all right? Again, if your answer is given to you as fractions, right? I know that this is also 1 over 10, okay? But if it's given to you as a fraction, then what you would need to do is you would need to figure out what is the decimal value for each of those fractions in order to make sure that you have the correct answer, all right? So again, again, I could have just multiplied 5 times 2 and got 10, and then 10 times 2 and got 100, and got 10 over 100, and then simplify that, okay? So don't want to make this complicated. All I'm saying there is just giving you some tips. If you were doing this in a multiple choice question, right? Sometimes it's going to, again, have multiple answers. And again, if it's not written as a, fraction, you get your answer as a decimal, then all you got to do is put that into decimals, 1 over 10, and it's going to figure out which one is the equivalent one. All right. Now let's look at the next one. All right. Matter of fact, I want you to pause the video and I want you to do the next one on your own. All right, a deck of cards contains 6 equally shaped cards. What is the probability that Donovan grabs a heart, okay, replaces the card, okay, that's key, and then he grabs a circle, all right? So he grabs a heart, all right? So we're looking for the probability of getting a heart. And then we're going to multiply that times the probability of getting a circle. Okay? So, what's the probability of getting a heart? Well, there are 2 hearts out of 1, 2, 3, 4, 5, 6. Again, it tells us that we have 6 cards. So 2 out of 6. And then times the probability of getting a circle. Well, that is also 2 out of 6. And again, I'm grabbing the card, I'm putting it back so my total doesn't change. And then I multiply this, okay? All right. When I do that, okay, again, I can, really when we're multiplying fractions, we're just multiplying across. So 2 times 2, that would be 4. 6 times 6, that's 36. Okay, again, I know that this simplifies by dividing it by 4, and I know that that is going to give me 1 over 9. Okay, now imagine, I just want to show you, imagine you did this in decimals, right? Imagine you did this in decimals and you put in, all right, we said we were doing 2 over 6. So 2 over 6 times 2 over 6, okay? And we got, we got 0.1111111, right? So if you do that, that is likely going to be what you get. It's going to give it to you as a decimal, okay? Well, the answer choices, right? Say, one of the answer choices was 1 over 9. Well, then I would just put in all of my answer choices, and then I match up which one is equivalent to what I got as the decimal, okay? So you may need to do that, okay? I know in the practice, all of your answers are going to be written as fractions. Well, decimals is likely going to give it to you as a decimal, so you're going to need to be able to match the fractional value to the decimal value, okay? All right, hey, now, guys, I could end the video right there. There are several more examples, but those are just for you to do on your own, okay? All right, and so I want you to, I'm gonna end the video because I have noticed that a lot of students have not really paused the video and checked their answers. So I'm gonna end it right there, and you have to do the entire right side of the page by yourself and raise your hand when you are done. Hey, thanks so much for watching this video. Hopefully you've learned how to find the probability of 2 independent events.